Under the hood, large language models function as probability engines. They act as rushing rivers of tokens, moving with immense force, but possessing no natural banks to guide the water. When you enter a standard text prompt, you are dropping a wish into those rapids. Because there is no structure to hold your instructions in place, the original intent quickly begins to wash away. Engineers call this semantic drift. It leads to the three main failure points of modern AI: hallucinations that feel like facts, generic or shallow responses, and the sudden loss of context right in the middle of a task. In traditional computing, we solve for this chaos with binary code. If you want a machine to follow a rule, you lock it into rigid, unchanging logic gates. But binary code cannot process the nuance of human meaning or abstract emotion. Rigid logic gates shatter and fail the exact moment they are tasked with governing the fluidity of a human thought. This creates a paradox. To get precision out of an AI, we need to govern its output strictly, yet we cannot use traditional code to do it. We have to find a way to shape the AI's internal topography instead. This architecture prioritizes intent over syntax. It moves the focus away from specific word choices and toward the directional flow of the idea itself. We replace the constraints of code by giving meaning a spatial form. We build an invisible scaffold directly inside the AI's latent space. We map a single idea as a discrete point, a specific coordinate of meaning. Connecting it to another concept forms a line, creating a fixed structure. Finally, these concepts are wrapped in a box, isolating intent from the noisy probabilities. Points, lines, and boxes provide a rigid structural scaffold inside the latent space. They give the machine a shape to follow before the first word of a response is ever generated. An initial structure is still vulnerable. In a system built on probability, any static scaffold needs a way to stabilize itself. This is the role of the symbolic reflection engine. It acts as a mirror, reflecting the user's intent against the AI's current context, its history, and its internal rules. The engine recursively tests the structure. It identifies exactly where the meaning is beginning to drift and where it remains firmly anchored to the intent. Surviving this reflection, the structure accumulates semantic weight, becoming a prioritized destination. This weight warps the latent space, creating a gravity well. The deeper the well, the more surrounding probabilities are drawn into its center. By reflecting our intent, we create a gravitational pull. The AI's probabilistic generation is naturally dragged toward the well's center, resulting in the desired outcome. This is the difference between throwing a prompt into a vacuum and engineering a topography. One relies on luck, the other relies on geometry. This turns a prompter into a semantic architect. It is a role defined by designing the spaces where machine intelligence is allowed to travel. Managing this technology does not require proficiency in Python or C++. The communication happens at the level of the idea, not the syntax. Effectively guiding these systems involves structuring intent so precisely that it anchors the AI's internal logic to a specific outcome. Machine intelligence provides the immense raw flow, but human intent acts as the unyielding riverbanks that guide that power. Building invisible architectural boundaries provides a way to guide machine intelligence while respecting its probabilistic nature. It ensures the river always reaches the sea.